Hello to everyone. Ses biraz yüksek mi? Ses biraz yüksek mi? Hello to everyone. Thanks to Mr. Serkan Güler for his great presentation, and we are also thankful to Electrotechs, what they are gifted to our industry, and also for our other technology suppliers and also raw material suppliers, because as we are the mattress producers, as you know, we are just making assembly. And what the industry gave us from the raw material and from the machinery side, we are using that, and we are as strong as what they serve to us. Today, I will talk a little bit about the quality, efficiency, and the new production methods. And Mr. Serkan presented very well about the new production styles. And also he talked about the IoT and the Industry 4.0. Plus, I will add a little bit more about the Human 5.0 after the Industry 4.0, because it's the most logical way if you combine a little mix at the right. If you can get the right mixture with the Industry 4.0 and the Human 5.0, I think it's the best way. Let's start. Yes, all of us are trying to handle the business about the quality, efficiency, profitability, and this is the iceberg, but also there is another big part of the iceberg what we cannot see. If you want to get the efficiency, profitability, quality, also you have to fix many other issues to get the perfect point. A cost of a mattress is roughly near around 87% comes from the material cost, and the 13% comes from the labor cost and the general production costs. And where there is a product for the customer, there is a value stream. And the competition is reserved to see it, says, rather than the shoe at the Learning to See book. And some of the operations are non-value added and some of the operations are value added. If you can cut the some non-value added operations, you can fix your cost, you can fix your efficiency, you can fix your quality. Here I will mention about three different aspects for the efficiency. First is the balancing. Second one is the reducing the 7 wastes, and the third one is the work ergonomics. Bir geriye alabilir miyiz? First, balancing. The red line is the takt time. Takt time means the period, the frequency of what the customer wants product of you, and you have to balance all of your operations according to your takt time. Otherwise, some of the operations, some of the workstations will be empty, and some of them will be overloaded, and your cycle time will be equal to your longest operation time. So you have to look all of your operations very detailed, and you have to find what you can do. For every step, for every second, you have to see, you have to measure, and you have to analyze what are the opportunities to cut or combine together. Here is you can see one of balancing sample. Before the balancing, there is just a small operation with 5 employees, and you see the unbalancing points at the graphic. You have to look, as I said before, very detailed. And after the balancing, you can see an operation can fix from 5 employee to 4 employee, and the cycle time to actual takt time, the ratio is 100%. So you can cut 20% from your labor cost. And another point, yes, we said human 5.0, but also you can use some digital tools to understand and be sure about you make the right balancing with your operations. You can use different softwares like Rockwell Arena, like visual components. Some of them are really nice HMIs. This is the first simulation of our mattress line. What we measure before we design the mattress, our assembly line, and we see how many mattresses we can produce, and after that we sign the contract and we go on for the production. As you can see, it's at the 8-hour shift, how many mattresses you can produce. Geçebiliriz bir tane de. And the most important point after the simulation, all the loading have to be equal or close for every workstation. And the second point is reducing the 7 waste. It's a main principle of the lean production, or the Toyota way. Inventory, too many inventory is a waste. Waiting is a waste. Defects, reworks are waste. Overproduction, overmotion, transportation, overprocessing, all of them are the 7 sins for the production companies. So you have to look where you are losing, which points makes you waste and inefficient. For example, thanks to our team, they made an analysis about the feeding the inner spring units to the assembly line. They made detailed analysis, spaghetti diagrams. They made the brainstorming together, and they give the importance and the hardness of these potential solutions. And after that, they accepted to start a Kanban project, and they designed special carriers for the side rails. They designed Kanban cards, and they reduced the overmotion and transportation, inner transportation, to 0. At the second point, now you are seeing the value stream map for the current situation. And here is the next situation. They changed the system completely from pull system to push system. And another important point is the standard job. It means if any operation made by anybody, every time, at any time, everybody have to do the same thing in the same way, in the same method, and at the same time. So it always aims to reduce the differentiation and the standard deviation from person to person, operation to operation. And now you are seeing some of our standard operation sheets. For example, you can see what is the tip point to do this operation, where they have to be aware about the operation, what is the critical point, and what time they have to start, they have to finish this operation. Another point, they also seen a waste to move to handle the roll pack pocket spring units to the assembly line. You see the spaghetti diagram. And they also made the brainstorming again, and they find a solution to integrate an bail opener and roll opener to the assembly line. They added some extra conveyor belts to fix the operation at the same time. And you see the efficiency lose, the weightings decrease to the 70% less. And the other point, as we are the mattress producers, all of us are serving to many different markets. And all the market needs different types of the mattresses. Some markets needs inner spring mattress, some markets needs foam core mattresses. And it means much more SKU, much more model, means much more changeover and much more setup. And every setup, if you cannot do the setup at the short times, means a break and unplanned stop. Now I will show you a video from the formula. First, you will see the first video from the 1950s, and after that, you will see the new version of the pit stop at the formula from the 2010s.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
67 seconds at the 1950s. And this is 2013 from the Melbourne. Quicker, but still have time. So reducing the setup times, changeover times is really critical for our industry because of our product game and about our product variety. So we have to change from one model to one batch to other batch in the seconds. So that's just a simple example what they are doing at the Yataş. We are producing 100% foam encased mattresses. This video shows one-piece flow and also shows the CMET, single minute exchange of the dies. Now he's preparing the mattresses side rails. And after that, he's changing the another model, another size, and so he have to use another side rails. Now he switched the other batch to the other size. It's easy and lean. Another point is we are working with the really expensive equipments, and every equipment has too many different electronical sensors, some controllers, too many mechanisms, too many mechanics, and you have to be you have to care about the condition of your machines for the maintenance. With the unplanned subs, with the breakdowns means unplanned stops, and it means efficiency loss. So to reduce the breakdowns, the broken parts, some sensor stuff, if you want to reduce them, also you have to clean your machines, you have to control the critical points of your machines, you have to tighten some of the screws, and you have to make regular lubrication to reduce the breakdowns. And now, at this assembly line, you are seeing every person has a number, has a code, and every person, every shift at different days, they have to clean different points, they have to check, they have to control, they have to tighten, they have to lubricate different points at the assembly lines. And we are detailing all these points, how they have to clean, what they have to use, and we are giving detailed one-point lessons. And you see the you see the trend of these timing lines, how that's going. And also another point is escalation. If there any break, if there any unplanned stop, there is an escalation chart to inform at a path. And Lord Kelvin says, if you cannot measure it, you cannot improve it. And Peter Drucker says, the famous management consultant says, if you cannot measure it, you cannot manage it. So manufacturing execution systems and IoT, also Serkan mentioned at his presentation, is really important for us to see. We are collecting data from our production lines, and also another point, we have an unknown button. If there is any abnormality, if the person see any abnormality, he is pushing this button, and we completely stop the line. We completely stop the line, and there we have a horn, and we have a lightning, and the supervisor of the line is going to that point and asking, how can I help you? We call it stop for don't stop. And overall equipment efficiency, OEE trends, we are always collecting data. And another point is the 5S, sort, set in order, shine, standardize, and sustain is another important point to keep the problems visible. Here you are seeing a map at which point of our production lines, what kind of dirtiness sources we have, and we are measuring how many minutes we are expanding to clean these points and to control these points, and our aim to reduce the source of the dirtiness. Here is another example, and this is the our visual plant standards. Some of the examples from the our 5S applies. And also another point, as I mentioned before, visual management and autonomous management. We are collecting data and we are looking to reports and we are talking about it, what we can do together to solve and do it better. And another point is the work ergonomics. Yes, we have a, we are, as the mattress industry, we are better than the furniture industry. We have much more automation. We have much more automated products and machines. But also we are still using too many labor and manpower. So ergonomics are so important. Also you have to look to all of your operations from the ergonomics. As you can see from this chart, every motion, every position has a hardness point, and you have to look to your operations. And this is before of the improvement. The total score is for these three operations 261, and after the improvement from 261, we came to 120, and we balanced the hardness of the operations at every station to same. And also we eliminate the third operation. And another point is the autonomous maintenance. Also you can call it TPM, total productive maintenance. These are the fault cards. We have three different kinds of the fault cards. The blue ones is for the maintenance guys, the red ones for the operators, and the yellow ones is about the health and safety for the labor. So these are the most important one. We have to solve the yellow ones at the same day. And we are using these cards, we are hanging it where we see in the problem, and also we are pointing from the layout. Now you are seeing 1, 2, 3 maintenance fault card, 1 operator fault card, and 1 health and safety fault card. And this is when we hang the card and when we unhang the card. You are seeing at the graphics. And also, you have to talk about the maintenance and also the breakdowns for the machines. We are talking every morning at every problem about the maintenance. If we had a problem, we are always asking 5 times why. We are. This is the aim of this analysis. 5-why analysis is always aims to find the source, real source of the breakdown. You are seeing little kaizens from the Gemba. First, this is the first air valve, and we had a problem about this air valves, the air pressure, and they sign for the correct air pressure to this semi-automatic valve, and after that we switch an electronic one to fix the problem as a Pokyake solve. There is another Kaizen. Before it was, we cannot see the inside of the knife unit, and if there is a problem, the angle of the knife, we couldn't sense it before the problem, but now the problem, if there is a problem, we can see it. And this is another Kaizen to make to clear the bottom side of the machine. This is Kaizen to collect the side waste of the polyethylene film. This is another Kaizen to fix the lubrication and control points of the machine. And these are every control points has some cards. These are the flip cards. And if they are doing the control at the right period, they are hanging the backside to these ticket areas. And you see these are the cleaning time for that machine. You see the Kaizens, more than 10 Kaizens. From 30 minutes, we decrease the time for the 8.9 minutes. And also, these are the standard maintenance sheets for our maintenance guys for critical machines and the critical parts. If there is a problem at that critical machine, every maintenance staff is making the right operation, what we write here, as what we write here. And these are shows the lubrication points. These are the Kaizens from the fault cards. We are hanging fault cards, as I said before, and after that, we are unhanging the fault card with a Kaizen. We are always standardizing a problem. That's our aim. And these forms are shows what was the problem and what was the maintenance guys do, and the source of the problem, 5Y analyze. You see there was a problem for the resistance connection, and they fixed this problem with this Kaizen. And also we are looking, we are making some surgery operations to parts what we change after a breakdown. And we are looking to part why it's broken. And these are the quality tools what we are using. We are always using 7 steps quality methods. First, we are defining the problem. Second, we are analyzing the current situation. Third, we are setting the targets after the Kaizen, what we are aiming, and after that we are making the cause and root analyze. And we are finding the solutions, potential solutions, and we are doing it. And after that we are looking, does it solve or not? And also we are standardizing again with the standard operation pages. And you see, for this quality problem, it starts from the 4.5 and we close it at the less than 1. And this is the standardization. Another problem about the T-batch quality, another Kaizen project about the T-batch problems. They always follow the same path. You are seeing some improvements to solve this problem. They added a guide for the T-batch operator to here. They changed the looper, they changed the needle, and they fixed it at the standard operation page. They changed the apparatus. And you see from here, from 5% to 1%, they arrive at this quality problem. This is another problem about the T-batch. And the main issue about these improvements, we are always making these improvements with the team, because an operation known by bestly from the whom is doing that operation. We always believe that. This is some POCOK samples. We are always making maps to our POCOKs, and we are always checking they are active or not. These are the limit samples, because we are making the quality control by the human eye, and somebody says this is okay, this can pass, and somebody says this cannot pass. And also we are comparing to the quality control operators to about their decisions about the samples, if they are saying the same thing or not, and if there is a problem, we are giving education and we are fixing their eyes about to pass or not for that issue. And at the 2017, we have a 12% rework ratio for the quality at the quality control line. At the 2019, we came to 2.5%, and this year we are going on the 1.95 and between 2%. So 5 times we reduce our rework ratio with the teamwork. And these are the cycle times from 2017 to 2022. At the 2017, we were making assembly at our assembly lines at every 56 seconds, and this year now we are at 24 seconds. Thank you for your attendance, and if you have any question, I will be happy to answer it. I think there's no question. Thanks so much.